take a look at problem number 1. We got 4x squared minus 6x minus 6 over 2. And the instructions are, divide the polynomial numerator by the monomial in denominator. Whenever you have polynomial up on top, multiple terms, and you got a single term down below, you can split this into separate fractions. So I'll put the 4x squared over 2 minus 6x over 2 minus 6 over 2. And then you simplify these. 4 divided by 2 is 2x squared, minus 6 divided by 2 is 3x, minus 6 divided by 2 is 3. And that's our answer. Our second problem. We got 4x to the fourth minus 3x squared minus 6x to the third plus 6 over 2x to the third. Same idea. We got multiple terms up on top, and we got a single term in the denominator. So we're going to split this into separate fractions. So I got 4x to the fourth over 2x to the third minus 3x squared over 2x to the third minus 6x to the third over 2x to the third plus 6 over 2x to the third. 4 and 2 both divisible by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Here we have x to a power over x to a power. Remember, you subtract small exponent from larger one. 4 minus 3 is 1, so we're going to have x the first where our larger exponent was, which is up on top. Minus, can't do anything with the numbers. Here we have x to a power over x to a power. Again, you subtract smaller exponent from the larger one. 3 minus 2 is 1, and we have x the first where larger exponent was, which is on the bottom. Minus 6 and 2, both divisible by 2. 6 divided by 2 is 3, 2 divided by 2 is 1, and these x thirds drop away. Plus 6 and 2, both divisible by 2. 6 divided by 2 is 3, 2 divided by 2 is 1, and we leave the x down there, because there are no x's up on top. So that gives us 2x minus 3 over 2x minus 3 plus 3 over x to the third. Now we don't worry about trying to write in standard form because this isn't a polynomial, so there's no standard form on this. So if you're wondering, should I rearrange this up to begin with? You could if you wanted to, but it didn't matter because, like I say, this is not a polynomial. Okay, third problem. Want to find GCF of 56, 17, and 40. Is that what it says? GCF. Huh. It's an interesting problem. Well, you think the largest number divides into all of them, and there isn't any. But 17 is prime. 56, if I were to break it down, we got 2 times 28. 28 is 2 times 14. 14 is 2 times 7. So it looks like this is what I'm working with. And since 17 is prime, I don't have 17 in here, there is no GCF. So if I were to put 1, the only thing you would have is your GCF is 1. Okay. Number 4. We got 3x squared y (9xy) and want GCF. Okay, let's start with the numbers first. We got 3 and 9, so we're looking for the largest number divides into both those, which would be 3. Now for the x's, we got 2 x's here, we got 1 x here. It's always the one with the smaller exponent. So we're going to bring out x, or x to the first power. And this is y to the first, this is y to the first. The one with the smallest exponent would just be y, or y to the first. So our GCF will be 3xy in that problem. Okay. Number 5. We got 5xy. We got 3x squared. And we got 7x to the third y. First off, let's start with our numbers. We got 5, 3, and 7. The largest number divides all those would be 1, so that's nothing really. Now the x's. Here we have x to the first, x squared, x to the third. It's always one of the smallest exponents, so it'll be x to the first or x. Now for our y's. Here's a y. This does not have a y, and this has one y. Since this one doesn't have a y, then our GCF is just x. You cannot have a GCF of a y if one of them doesn't have a y at all, because they all have to have it in common. Greatest common factor. Okay, number 6. We've got 3xy plus x squared. You might look at this and say, well, it's not in standard form. Maybe it's not. Maybe it is. If you go by y's, it isn't standard form. This is y to the first power, no y. Now, if you do x's, then it needs to be reversed. You should have x squared first plus 3xy. So, like I say, it all depends on which variable you pick. I like to go alphabetical myself, so I would go off of x's. So I would rewrite this. I'd have x squared plus 3xy. Okay, now GCF. They both have an x in common, so I'll factor out an x. And that gives us x plus 3y. Because here we had 2 x's, we took one away, so that leaves a single x. And I take this x away, and that just leaves me the 3y. Number 7. We got negative 35x to the third. And minus 15y. 15y? I guess there are different variables. Okay, factor out the greatest common monomial factor. Okay. It's kind of a weird way to put it. And rewrite the expression. Okay, so let's factor out GCF. First off, the first term is negative, so I know I'm going to bring a negative out. This is what we had. One of our notes says if your first term is negative, bring out a negative. Now, 35 and 15, I'm looking for the largest number divides into both of those, which would be 5. Now, this has x's, but this one doesn't. This one has y's, but this one doesn't. So the variable y's, they have nothing in common. Remember, factor means to divide out. Negative 35 divided by negative 5 gives me a positive 7, x to the third. Negative 15 divided by negative 5 gives us a positive 3 in y. And that would be our answer. Okay, 3x y to the third plus 6x to the third y minus 9xy. And again, is it in standard form? Yes or no, I don't know. If we go by y's, y to the third, y, so it is in standard form. If we go by x's, no it isn't. Because the x to the third should be here, and then x, but we'll go with it how it is. Okay, look at the numbers. 3, 6, and 9, the largest number divides in all those is 3. Now here we have an x, here we have 3 x's, and here we have an x. So we want to bring an x up. Always one with the smallest exponent. If you have x, that's like x to the first. Now y's. We got y to the 3 y's, 1 y, 1 y. Always bring out the one with the smallest exponent, so we'll bring out y to the first. Okay, 3 divided by 3 is 1. That x is gone, we took it out. We had 3 y's, we took 1 y out, so that leaves us 2 y's. Plus, 6 divided by 3 is 2. Had 3 x's, we took 1 x away, so that leaves us 2 x's. And now y is gone. Minus, 9 divided by 3 is 3, and that x and that y are both gone. We took them out in front. So we're going to have 3xy times y squared plus 2x squared minus 3. And that's our answer. Okay, number 9. We got x is 7th over x is 6. Well, if you got x to a power over x to a power, you subtract a smaller exponent from a larger one. 7 minus 6 gives me 1. I'm going to have x the first where my larger exponent was, which is up on top. And then we put a placeholder of 1 down below. And x at first is x, and x over 1 is x. Number 10. BQ plus BT plus QY plus TY. Okay. GCF-wise, I look at all 4 terms. They have nothing in common. So now I'm going to use grouping. So group first 2 terms together, group last 2 terms together. First 2 terms have a B in common, so I'll factor that out, and that gives me Q plus T. My last 2 terms, the last group, has a Y in common, so I'll factor out a Y, and that gives us Q plus T. Now our goal was to get this parentheses same as this parentheses, which they are, so I'll factor out a Q plus T. To see what goes in your second set of parentheses, you can come up with the previous line and cross out the Q plus T's, and what isn't crossed out, which is a B plus Y, is what goes there. And that's our answer. Number 11. B squared minus BW minus 2B plus 2W. First off, I look at all 4 terms, looking for a GCF, and there's no GCF. 4 or more terms tells us we're going to use grouping. So group first 2 terms together, group last 2 terms together. The first 2 terms have a B in common, and that gives us B minus W. Last 2 terms have a 2 in common, and first term's negative, so bring out a negative 2. Remember our note, if your first term's negative, you always bring out a negative. And that gives us B minus W. Now our goal was to get this parentheses same as this one, which they are. So I'll factor out the B minus W. To decide what goes in your second set of parentheses, you can cross out the B minus W's in the previous step. And what isn't crossed out is what goes right here, which would be B minus 2. And that's our answer. Okay, number 12. We've got 40 CR minus 6 TY, bizarre variables, plus 5 RT minus 48 CY. This isn't looking promising, so I see a problem right away. But we'll see. Maybe it comes out. The reason why I said it's not looking promising is see how C, if I, there's no GCF in all 4 of the terms. If I group these 2 together and group these together, see how the C is in the first term here, but the C is in the second term here? That kind of indicates to me that maybe I got a problem. But let's try it. Okay. GCF, the first group, they have a 2 in common and a 2. So that gives us 20 CR minus 3TY. My second group, they have a nothing in common, so I can factor out a 1. And that gives us 5RT minus 48CY. Doesn't go anywhere, fails. This one we're going to need to rearrange. Now, I'm going to leave this 40CR here. That's fine. Minus 6TY. That's fine. But here I'm going to reverse these. So I'll put the minus 48CY here. And then plus 5RT here. Doesn't mean it'll work. But we'll try that. Because at least you got to have a pattern. So let's try that. Okay. These have a 2 in common, and that gives us 20 CR minus 3TY. These have a nothing, negative 1, and that gives us 48 CY. And I see right away it's not going to work. So let's try to rearrange again. Okay. I'm going to put, this time, that failed, 40 CR, and I'm going to put this C with it. So minus 48 CY. Okay, now notice our pattern here. C's are the same, so we put those in the same group. And R goes first, and Y went second. So as I rearrange the last two terms, I want to put the one with R in it first, which is the 5RT. And then the one with the Y next, which is the minus 6TY. Okay, now I got a good feeling about this one. Okay, so I'm going to factor out GCF. The first group would be 8, I guess, 8C. And that gives us 5R minus 6Y. Second group has a T in common, so I factor out a T, and that gives us 5R minus 6Y. Again, our goal was to get that parentheses same as that, which they are, so it's working. 5R minus 6Y. And again, to see what goes in your second set of parentheses, you can come up here and cross out the 5R minus 6Ys, and what isn't crossed out is what goes right here, which would be 8C plus T. And that would be our answer. That one is an interesting one. Okay, 13. We got x squared plus 7x plus 12. Let's see, GCF, there isn't any. Groupings, 4 more terms. PSD, x squared, x, no number in front of our x squared. Remember, with PSD, we take our number at the end, 12, and we're going to create our 3 columns. P column, we list all products, give us 12. We got 1 times 12, 2 times 6, 3 times 4. And the S column, we want to add those together. 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. And the difference column, we want to subtract, smaller from larger. 12 minus 1 is 11, 6 minus 2 is 4, 4 minus 3 is 1. Number we're looking for is a number in our middle term, which is 7, which is right here, which means we use 3 and 4. Our larger number that we're using 3 and 4, so larger one is the 4, will always be the same sign as the middle term, which in this problem is positive. The number I circled in the S column, S for same signs, means they're both positive, both negative. Since this one's positive, then this one has to be positive. And that's our answer. Number 14, x squared minus x minus 6. Okay, GCF, no, don't have anything common. Groupings, 4 more terms, that doesn't fit. PSD, x squared x, no number in front of our x squared. We take the number at the end, ignoring signs, so work with 6, number at the end. Come up with our 3 columns. We list all products, give us 6. We got 1 times 6, 2 times 3. Add them. 1 plus 6, 7. 2 plus 3 is 5. Subtract them. Smaller from larger. 6 minus 1 is 5. 3 minus 2 is 1. Always looking for the number in a middle term, which is 1, which is right here, which means we use 2 and 3. The larger number that we're using 2 and 3, so a larger one is the 3, will always be the same sign as the middle term, which is negative. The number I circled in the difference column, D for different signs, means one will be positive, one will be negative. If this is negative, then this has to be positive. And that's our answer. Let me start a new page and we'll look at number 15. Let me save this. Game I'm playing. Close that. There you go. Not while I'm doing this, mind you. Let's see. Number 15. 2x squared minus 4x minus 16. Okay. First thing we'll do is factor out GCF. Because I notice they all have a 2 in common. So that gives us x squared minus 2x minus 8. So GCF. Now look at what's inside of parentheses. We got x squared, x, no number in front of our x squared. That's PSD. PSD, we take the number at the end, ignoring the sign, so we take the 8. Come up with our 3 columns. Write down all products, give us 8. We got 1 times 8, 2 times 4. Sum column, add them. 1 plus 8 is 9, 2 plus 4 is 6. Difference column, subtract smaller from larger. 8 minus 1 is 7, 4 minus 2 is 2. The number we're looking for is a number in a middle term, which is a 2. So we're going to use 2 and 4. Now the 2 doesn't change anything, but you have to keep carrying it down. So we got x, 2, x, 4. The larger number that we're using in the P column, we're using 2 and 4, so the larger one is the 4, will always be the same size as the middle term, which in this problem is a negative. The number with circles in the difference column, D for different signs, one will be positive, one will be negative. If this is negative, then this will be positive. And that's our answer. 16. M squared minus 5mn minus 24n squared. Now there is no GCF. Groupings, form, or terms, that doesn't fit. PSD. We have m squared, no number in front of our m squared. So that fits. I'm going to take our number at the end, ignoring signs, so work with 24. Come up with our 3 columns. All products give us 24. We got 1 times 24, 2 times 12, 3 times 8, 4 times 6. Add those. 1 plus 24 is 25. 2 plus 12 is 14. 3 plus 8 is 11. 4 plus 6 is 10. Subtract them. Smaller from larger. 24 minus 1 is 23. 12 minus 2 is 10. 8 minus 3 is 5. 6 minus 4 is 2. Number we're looking for is a number in the middle term, which is 5, which means we use 3 and 8. Now our larger number in the P column we're using 3 and 8, so the larger one is the 8, is always the same size as the middle term, which in this problem is negative. Number I circled in the difference column, D for different signs, one's positive, one's negative. If this one's negative, then this one has to be positive. And how we handle those extra variables is I'm going to put in here and in here. Reason why I do that is look at the pattern. M squared, M, no M, we put M and M. Going backwards. N squared, N, no N, we put N and N. Okay, number 17. 2x squared minus 16x plus 24. And I completed the factories and trial there. Okay, ignore all those instructions. Just factored. Okay. First thing I notice is they all have a 2 in common, so it's got a GCF. So I'll factor a 2 out, and that gives us x squared minus 8x plus 12. Now looking at what's inside the parentheses, we got x squared x, no number in front of our x squared. That's PSD. So we're going to take number at the end, 12, come up with our 3 columns. All products give us 12. We got 1 times 12. We got 2 times 6. And 3 times 4. S column, when I add those together, 1 plus 12 is 13. 2 plus 6 is 8. 3 plus 4 is 7. Difference column, subtract smaller from larger. 12 minus 1 is 11. 6 minus 2 is 4. 4 minus 3 is 1. Number we're looking for is a number in our middle term, which is 8. Which is right here, which means I use 2 and 6. Larger number that we're using 2 and 6, the larger one's a 6, will always be the same sign as the middle term. Number with circles in the S column, S for same signs, so if this one's negative, this one has to be negative. And that would be our answer. Okay, now let me open up pop here. My throat's I've been sick. Let's take a look at number 18. We got 2x squared plus 3x minus 14. Okay, first method, GCF, there isn't any. Groupings, 4 more terms, that doesn't fit. PST's close, but there's a number in front of the x squared. So key number. Key number is when you have an x squared, x, no x, and there's a number in front of your x squared. So with key number, we're going to take the number at the beginning times the number at the end, ignoring signs. Number at the beginning times the number at the end. So 2 times 14. That gives us 28. I'm going to write down all products give me 28. I got 1 times 28, 2 times 14, 3, no, 4 times 7. Add them. 1 plus 28 is 29. 2 plus 14 is 16. 4 plus 7 is 11. Subtract them. Smaller from larger. 28 minus 1 is 27. 14 minus 2 is 12. 7 minus 4 is 3. Number we're looking for is a number in a middle term, which is 3, which is right here, which means we're going to use 4 and 7. Now we're going to rewrite our middle term using those 2 numbers. Our larger number that we're using 4 and 7, so a larger one is 7, will always be same sign as the middle term, which in this problem is a positive. So we got plus 7x. Number with circles in the difference column, D for different signs. One will be positive, one will be negative. If the 7's positive, then the 4 has to be negative. Then we want to factor by grouping. The first group has a x in common. And that gives us 2x plus 7. Second group has a negative 2 in common. They both are divisible by 2. Remember, if your first term is negative, you always bring out a negative. And that gives us 2x plus 7. Now our goal was to get this parentheses same as this parentheses, which they are. So I'll factor out a 2x plus 7, and that gives us x minus 2. And that's our answer. Number 19. 12x squared minus 5x minus 2. Let me see. GCF, there isn't any. Groupings, 4 more terms, no. PSD's close, except for there's a number in front of the x squared. Key number. X squared, x, no x, there's a number in front of the x squared. So with key number, we take our number to beginning times the number to end. So I got 12 times 2, which gives us 24. Come up with our columns. List all products, give us 24. We got 1 times 24, 2 times 12, 3 times 8, 4 times 6. The S column, add those together. S for sum. 1 plus 24 is 25, 2 plus 12 is 14, 3 plus 8 is 11, 4 plus 6 is 10. Difference column, subtract smaller from larger. 24 minus 1 is 23, 12 minus 2 is 10, 8 minus 3 is 5, 6 minus 4 is 2. Always the number we're looking for is a number in a middle term, which is 5, which is right here, which means I use 3 and 8. We're going to rewrite our middle term using those two numbers. The larger number in the P column that we're using 3 and 8, so larger one's the 8, will always be the same sign as the middle term, which in the problem is negative. Number I circled in the difference column. D for different signs. It means one will be positive and one will be negative. If the 8's negative, then the 3 has to be positive. Then we factor by grouping. So group first two terms together, group last two terms together. First two terms have a GCF of 4x, and that gives us 3x minus 2. Second group has nothing in common, but if they have nothing in common, you can always bring out a positive 1. And it remains 3x minus 2. Now our goal was to get this parentheses same as this, which they are. So I'll factor out the 3x minus 2. To see what goes in your second set of parentheses, you can come up here and cross out the 3x minus 2's. What isn't crossed out is what goes right here, which would be 4x plus 1. And that's our answer. Let's take a look at number 20. For 40x to the third y minus 70x squared y plus 25xy. Now, if I jumped right in and tried to do one of the methods, it wouldn't work very well. Always look for your GCF. Makes your problem simpler before you begin. I notice here they're all divisible by 5, I think is the largest one, and they'll have a y. So I factor out a 5y. 5xy. Okay, 40 divided by 5 is 8. Had 3 x's, took 1 away, so it leaves me 2 x's. Took that y away. Minus 70 divided by 5 is 14. We had 2 x's, took 1 away, so that leaves a single x, and that y is gone. Plus 25 divided by 5 is y, or 5, and that x and that y are both gone. Much easier to work with now. Looking at what's inside the parentheses, I see I have an x squared, x, no x, number in front of the x squared. That's key number. With key number, we're going to take the number at the beginning, the 8, times the number at the end, times the 5. And that's going to give us 40. Come up with our 3 columns. We got 1 times 40, 2 times 20, 4 times 10, 5 times 8. Add them. 1 plus 40 is 41, 2 plus 20 is 22, 4 plus 10 is 14, 5 plus 8 is 13. Subtract them, smaller from larger. 40 minus 1 is 39, 20 minus 2 is 18, 10 minus 4 is 6, 8 minus 5 is 3. Okay. Number we're looking for is a number in a middle term, which is 14, which is right here, which means we use 4 and 10. Now the original GCF just carries down, doesn't change anything. And we're going to take those two numbers and we're going to rewrite our middle term using those. So larger number that we're using 4 and 10. So larger one in the P column is the 10. Will always be the same sign as the middle term, which in this problem is negative. Number I circled in the S column. S for same signs, both positive, both negative. Since the 10 was negative, the 4 will be negative. And I want to factor by grouping. Now the 5xy just carries down. The first group here, they have a 2 and an x in common. And that gives us 4x minus 5. Second group has nothing in common, but first term is negative. Remember, if first term is negative, you always factor out a negative. So factor out a negative 1, and that gives us 4x minus 5. Our goal was to get this parentheses the same as this, which they are. So I factor out a 4x minus 5. And that leaves us 2x minus 1 inside our second set of parentheses. And that's our answer. Okay, 21. 2v squared plus 3v plus 1. Well, this would be key number again, because we have v squared, v, no v, and there's a number in front of our v squared. So we're going to take our number at the beginning times the number at the end, ignoring signs. Number at the beginning times the number at the end. So 2 times 1 is 2. We'll write down all products give us 2. We got 1 times 2. Add them. 1 plus 2 is 3. Subtract them. 2 minus 1 is 1. Number we're looking for is always a number in the middle term. So we're looking for the 3, which is right here, which means we'll use 1 and 2. Okay, remember the key number we rewrite in the middle term using those two numbers. The larger number that we're using 1 and 2, so larger one is a 2, will always be same sign as the middle term, which is a positive. Number I circles in the S column, S for same signs, both positive, both negative. If the 2 is positive, then the 1 has to be positive. Okay, we'll factor by grouping. First group has a 2 and a v in common, and that gives us v plus 1. Remember, when everything disappears in factoring, you always left the 1. You never left the blank. Now here, they don't have anything in common, but I can always factor out a positive 1, and that gives us v plus 1. Our goal is to get this parentheses same as this, and they are. So I'll factor out a v plus 1, and that leaves us 2v plus 1 in our second set of parentheses. And that's our answer. We got 9x squared minus 25. Okay, GCF, no. Groupings, 4 more terms, no. PSD and key number, both 3 terms, no. Dots, 2 terms of the minus unit. Yeah, that looks like it might work. Difference 2 squares. So we're going to try to rewrite it as something squared minus something else squared. Remember, we take a look at each individual piece and you ask yourself what times itself gives you that. For example, 9 is 3 times 3. X squared is x times x. And 25 is 5 times 5. Now what's inside our first set of parentheses I'll label as F for first. And what's in our last set of parentheses I'll label as L for last. And this is just a formula. F plus L times F minus L. So everywhere I have an F in my formula, I'll plug in 3x. And everywhere I have an L, I'll plug in 5. So we got 3x plus 5 times 3x minus 5. And that's our answer. Number 23. We got 9x squared minus 16y squared. Okay, GCF, no. Groupings, 4 more terms, no. PSD and key number, both 3 terms, no. Dots, 2 terms of the minus unit. That fits. So we're going to try to rewrite it as something squared minus something else squared. Again, you look at each individual piece and you ask yourself what times itself gives you that. 3 times 3 gives us 9. X times x gives us x squared. 4 times 4 gives us 16. Y times y gives us y squared. I'm going to label what's inside the first set of parentheses F for first. Label what's inside the last set of parentheses L for last. And this formula is F plus L times F minus L. Everywhere there's an F, you'll plug in 3x, and everywhere there's an L, you'll plug in 4y. So we got 3x plus 4y times 3x minus 4y. And that would be your answer. Okay, number 24. We've got 16x squared minus 24xy plus 9y squared. Let's see, GCF, no. Groupings, 4 more terms, no. PSD, there's a number in front of the x squared, so definitely can't be that. Key number, x squared, x, no x, number in front of our x squared. It is key number. So I'm going to take the number at the beginning times the number at the end, ignoring signs. So number at the beginning times the number at the end. 4, 5, 144. Yeah, 144. So we got 1 times 144, 2 times 72, 3 times something. Let's see, 12, 48. 4 times, let's see, 3, 12, 24, 6. Yeah, 4 times 36. 5, no, 6, yes. 6 times, I'm having a little bit of trouble with my basic math here. 6 times 24, I think. Yeah. 7, no. 8, yeah. 8 times, let's see, it goes in there 1 time and then gives you 64. 18. 9 times 16. 10, no. 12 times 12. Okay, add them. We got 145, 74, 51, 40, 30, 26, 25, 24. Subtract them. 144 minus 1 is 143. 72 minus 2 is 70. 48 minus 3 is 45. 32, 18, 10, 7, and 0. Number we're looking for is a number in our middle term, which is 24. So we're going to use 12 and 12. Now, since they're both the same, there is no larger number. So you just pick one of them. And it'll be the same sign as middle term, which is negative. And number of circles in the S column. S for same sign, so it means they'll both be negative. If one of them is. Then we want to factor by grouping. So group first 2 terms together, group last 2 terms together. First 2 have a 4 and x in common, and that gives us 4x minus 3y. Second group has a negative, first term's negative, and a negative 3y. And that gives us 4x minus 3y. Again, our goal is to get this parentheses same as this one, and it is. So I'll factor that out. So we've got 4x minus 3y. And to see what goes in your second set of parentheses, you can come up here and again cross out your 4x minus 3y's. And what isn't crossed out is what goes right here, which is 4x minus 3y. Or you can write it as 4x minus 3y squared if you wanted to. Let me start a new page and then show number 25. Okay, 25. We got 25x squared minus 24x plus 4. Well, this would be key number, because we have x squared, x, no x, and there's a number in front of your x squared. Key number, we take a number at the beginning times a number at the end, ignoring signs. So we've got 25 times 4, number at the beginning times a number at the end, which gives us 100. Let's see. All product gives us 100. 1 times 100, 2 times 50, 3, no, 4 times 25, 5 times 20, 6, no, 7, no, 8, no, 9, no, 10 times 10. Add these. 1 plus 100 is 101. 2 plus 50 is 52. 4 plus 25 is 29. 5 plus 20 is 25. 10 plus 10 is 20. Subtract them. 100 minus 1 is 99. 50 minus 2 is 48. 25 minus 4 is 21. 20 minus 5 is 15. 10 minus 10 is 0. Number we're looking for is a number in our middle term, which is 24. I don't see it anywhere. I'm assuming it's prime. It can't factor, but let me check my products. Okay, 25 times 4 is 100. 1 times 100, 2 times 50, 4 times 25, 5 times 20, 6, no, 7, no, 8, no, 9, no, 10 times 10. Add them. Subtract them. Okay, I don't see any mistakes anywhere, which means I personally like this term the best. Prime. It means you can't factor it. Now, they're referring to it as not factorable. And I don't care which one you use. Okay, number 26. We've got 64 plus 27 y to the 6. First off, I don't like the fact that it's not in standard form. And so I'm going to reverse it. I'll put 27 y to the 6 first, then plus 64. Okay, let's start going down through our list. GCF, there isn't any. Groupings, 4 more terms, no. PST and key number are 3 terms, no. Dots and difference of 2 cubes are 2 terms with a minus between it, no. Sum of 2 cubes, 2 terms with a plus between it. So I'm going to try to write this as something to the third power plus something else to the third power. Now we ask ourselves what times this cell 3 times gives us each individual piece. For example, 27 is 3 times 3 times 3. The y to the 6 would be y squared. And I use a shortcut here. You take this power, divide by this one. 6 divided by 3 gives you 2. And 64 is 4 times 4 times 4. So I'm going to label what's inside the first set of parentheses as F for first. I'll label what's inside the last set of parentheses as L for last. This is the formula for the sum of 2 cubes. So we're going to have F plus L, F squared minus FL plus L squared. Now everywhere we have an F in our formula, we'll plug in 3y squared. Everywhere we have an L, we'll plug in 4. So we got 3y squared plus 4 times 3y squared to the second power minus 3y squared times 4 plus 4 to the second power. So that gives us 3y squared plus 4. 3y squared times 3y squared is 9y to the 4th minus 3 times 4 is 12y squared plus 4 squared, which is 16. And that's our answer. 27. We got 27y to the third minus 1. Okay, GCF, there isn't any. Groupings, 4 more terms, no. PST and key number both 3 terms, no. Dots, 2 terms minus between it. That works. But if we try to rewrite it as something squared minus something else squared, there's no way you can rewrite it as something times itself for 27. So we start going down. The next one is the difference 2 cubes, which is 2 terms minus between it. So we're going to try to write it as something third power minus something else third power. 3 times 3 times 3 gives us 27. Y times y times y gives us y to the third. And 1 times 1 times 1 gives us 1. I'm going to label what's inside the first set of parentheses F for first. I'll label this as L for what's last. The formula for difference of two cubes. We got F minus L, then F squared plus FL plus L squared. Now everywhere I have an F in my formula, I'll plug in 3y. Everywhere I have a L in my formula, I'll plug in y. So we got 3y minus 1, 3y to the second power plus 3y times 1 plus 1 squared, which gives us 3y minus 1, 3y squared. 3y times 3y is 9y squared, plus 3y times 1 is 3y, plus 1 squared is 1. And that's our answer. Okay, number 28. We've got 12x squared equals negative 2x. And want to solve this. Now I'm going to use zero factor property. That's really the only method we have at this point in this class. Zero factor property says you have to get 0 on one side. Well, let's start there. Take negative 2x and move it over. We like the number that's in front of the x squared to be positive. So take negative 2x over, it becomes a positive 2x equals 0. And now we need to factor the other side. Well, the other side factors with GCF. They both have a 2 in common, they both have an x. So factor out a 2x, and that gives us 6x plus 1. Remember, if you factor everything away, then you're always left with a 1. Okay, now zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I set 2x equal to 0, and I'll set 6x plus 1 equal to 0. Now 2x equal to 0, divide both sides by 2, and we get x is equal to 0. On this one, we take the 1 to the right side, becomes a negative 1. Divide both sides by 6, and we got x is equal to negative 1/6. And those would be our two answers. Okay, number 29. We got x squared minus 4x plus 1 equals negative 2. And basically, we want to solve it. Give you a lot of words here to say solve. But zero factor property says we have to have 0 on one side. So I'll take this negative 2 and move it over. So we got x squared minus 4x plus 1 plus 2 equal to 0. Which gives us x squared minus 4x plus 3 equal to 0. Zero factor property. Got 0 on one side, now we need to factor the other side. This is going to be a PSD because we have x squared x, no number in front of our x squared. So we take a number at the end, ignoring signs, and come up with our 3 columns. We got 1 times 3, and I guess that's it. Add them. 1 plus 3 is 4. Subtract them. 3 minus 1 is 2. Number we're looking for is a number in a middle term, which is 4, which is right here, which means we use 1 and 3. Now our larger number we're using 1 and 3, so our larger one is a 3, will always be the same sign as the middle term, which in this problem is negative. Remember our circles in the S column, S for same signs. So if this is negative, this has to be negative. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 1 equal to 0, and I'll set x minus 3 equal to 0. Which gives us x equals 1, and x is equal to 3. And those will be your answers. Okay, problem number 30. I think it's the last one. Yeah, it is. So I got 3x squared minus 13x minus 34 equals negative 4. First off, zero factor property says you have to have 0 on one side. So I'm going to take this negative 4 and move it over. So we're going to have 3x squared minus 13x minus 34. Take that over, it becomes a positive 4. Okay, negative 34 plus 4 gives us a negative 30 equals 0. Okay, now this is key number. Reason why it's key number is because we've got an x squared, x, no x, number in front of our x squared. Key number, we take our number at the beginning times the number at the end, ignoring signs. So number at the beginning times the number at the end. 3 times 30 is 90. We'll write all products give us 90. We got 1 times 90, 2 times 45, 3 times 30, 5 times something, 18. That looks like when I subtract them is what I want, but let me go ahead and finish it. 6 times 15, 7, no, 8, no, 9 times 10. Add them. Subtract them. Okay, 9, 1. Okay, so the number we're looking for is the number in our middle term, which is 13, which is right here. So we're going to use 5 and 18. Again, we're going to rewrite our middle term using those two numbers. The larger one we're using 5 and 18, so larger of those is 18, will always be the same sign as the middle term. So we'll have negative 18x. Number our circles in the difference column. D for different signs means one will be positive, one will be negative. If the 18 is negative, then the 5 has to be positive. Then I'll factor by grouping. First group has a 3 and an x in common, and that gives me x minus 6. Second group has a 5 in common, and that gives me an x minus 6. Now our goal was to get this parentheses the same as this, which it is. So I factor out an x minus 6, and that leaves us 3x plus 5. Let's try that again. Okay, zero factor property. We get 0 on one side, we factor the other side, we set each factor equal to 0. So I'll set x minus 6 equal to 0, and I'll set 3x plus 5 equal to 0. Here I take negative 6 over, gives us positive 6. Here I take the 5 over, becomes a negative 5. Divide both sides by 3, and we get x is equal to negative 5/3. So those would be our two answers.